Welcome to Aurelius Explainer. Tonight, while you lie here in the dark, settling into the quiet, something enormous happening beneath the surface of the sea. You will not see it. Almost no one ever does. But right now, as the light drains out of the sky on some far edge of the world, and the water turns from blue to grey to black, billions upon billions of animals are beginning to rise. They are lifting up out of the deep ocean all together, all at once, swimming slowly toward the surface under the cover of darkness, and before the sun returns, before the first pale light reaches down through the water again, every one of them will sink back down into the dark from which they came. This is the largest migration on Earth. It happens every single night, across every ocean on the planet, and it has been happening every night for longer than there have been human eyes to miss it. Scientists call it diel, vertical migration. Diel simply means daily, tied to the turning of the day and the night, and that is the whole heart of it. As the daylight fades, the animals climb. As the daylight returns, they fall. Up and down, a vast and patient breathing of life through the body of the sea. The largest movement of living things anywhere on the planet, and it is keyed entirely to the going and coming of the light. Let that settle for a moment. Not a herd of animals crossing a plain, not a river of birds flowing south for the winter. Those are migrations, yes, and they are wonders, but they happen once a year or twice along a single route in a single sky. This one happens everywhere, every night in every sea without rest. Billions of creatures, the combined weight of them beyond easy imagining, rising up through hundreds of meters of water as the world darkens and sinking down again as it brightens. A planet-sized rhythm, soft and silent, turning over beneath the waves while the surface looks calm and empty and asleep. And it is so easy to picture the sea as empty. We stand on a beach, or we look out from the deck of a boat, and we see a flat plain of water stretching to the horizon, blue and featureless, with maybe a gull turning overhead. We see the surface, and the surface tells us almost nothing. Beneath that smooth skin of water, there is a world that goes down and down, mile after mile in some places, colder and darker and stranger the deeper you go. And through that whole towering column of water, every night, life is moving, climbing in the evening, descending at dawn, the largest migration on Earth, hidden inside the most ordinary-looking thing in the world. Before we go further, I would love to know where you are listening from tonight. Somewhere there is a coast not far from you, or perhaps it is very far. Tell me, in the quiet, where in the world you are letting the day go. Leave a word in the comments if you feel like it. And if you are new here, you are welcome to stay a while. Settle in. There is no hurry tonight. We are going to take this slowly, the way the animals do, drifting down through the dark, together. And if you would like more nights like this one, you can subscribe, and the slow stories will keep coming whenever you want them. Now, why do they do it? Why would countless billions of animals haul themselves up through the water every dusk, only to sink all the way back down again every dawn? It seems like such an effort, such an endless, exhausting commute, repeated night after night without end. But there is a deep and simple logic to it, and it comes down to two things every living thing must balance: food and danger. The food is at the top, up near the surface, where the sunlight still reaches. Tiny plants of the sea catch that light and grow, the way grass grows in a meadow. And where there are these tiny floating plants, there are tiny floating animals that eat them. And where there are slightly larger animals that eat them in turn. The surface waters, the upper few hundred meters, are the green pasture of the whole ocean. That is where the eating happens. That is where life is rich and crowded and full. But the surface is also dangerous. Up there, in the daylight, you can be seen. A small fish near the bright surface is a small fish lit up like a lamp, easy to spot from below, easy to spot from above, easy for a hunter with sharp eyes to find and catch. In the lit water, you are exposed. You are a meal looking for a meal, and the things that would eat you can see you coming. So here is the bargain the animals strike, the oldest compromise in the sea. They come up to feed, but only when it is dark. As the sun sets and the light drains out of the upper water, the cover of darkness rolls in, and under that cover the small animals rise to the rich surface pastures and eat their fill, hidden in the black. They feast all night where the food is. And then, as the first light of dawn begins to seep back down through the water, they retreat, they sink, they drop down hundreds of meters into the dim and the dark below, where the daylight cannot reach and the hunters with their sharp eyes cannot find them. They spend the bright hours hiding deep in the gloom, and they come back up only when the darkness returns to shelter them again. Feed in the dark, hide in the deep, up at night, down by day. The whole great migration is that single ancient bargain, struck over and over by billions of creatures at once, all of them reading the same signal, all of them moving together. And what is that signal? What tells them when to climb and when to fall? It is the light itself. Each kind of animal seems to prefer a certain dimness, a certain exact softness of light, not too bright and not too black, a level of grey that feels safe and right. Scientists have a name for that preferred brightness. They call it the isolium, which simply means a line of equal light, an invisible level in the water where the light is just the way the animal likes it. And as evening falls and the whole column of water dims, that comfortable level of light rises toward the surface, and the animal rises with it, following the dimness up like someone following a familiar path home. Then at dawn, as light pours back into the upper sea, that comfortable grey sinks back down, and the animal sinks with it, chasing its own preferred shadow down into the depths. Think of it as the animals riding the light. Not the light you and I would see, not the bright glare of noon, but a faint and gentle level of dimness moving slowly up and down through the water with the turning of the day. The animals settle onto that level like a leaf settling onto a slow current, and they let it carry them. Up in the evening, down in the morning. The whole migration is just billions of creatures tracking a moving line of soft grey light, rising and falling with it every single day, forever. It is such a gentle thing when you understand it. Not a frantic stampede, not a panicked flight, a slow, patient, rhythmic rising and falling, keyed to nothing more violent than the dimming and the brightening of the sky. A tide of living things breathing in and out with the day, and it is so vast and so quiet and so far below the surface that for almost all of human history nobody knew it was there at all. But there came a moment when we caught the edge of it, by accident, without understanding what we had found. And it is one of the strangest little episodes in the history of the sea. It was during the Second World War. Ships were crossing the oceans in great numbers, and they carried a new and precious technology called sonar, which let them listen to the world beneath the water. The way sonar works is simple enough to picture. A ship sends a pulse of sound down into the sea, a kind of underwater shout, and then it listens for the echo. When that sound strikes something solid, it bounces back, and by timing how long the echo takes to return, the operators can tell how deep that solid thing is, shout, and listen, and measure. That is how a ship can find the seafloor far below it in the dark, by bouncing sound off the bottom and catching the echo on its way back up. It is how a ship can map the depth beneath its hull without ever seeing it. And as the sonar operators listened night after night, they began to notice something that made no sense at all. The seafloor was moving, not the real seafloor, of course. That stayed where it was, deep and steady below. But there was a second bottom, a second strong echo hanging in the water far above the true floor of the sea. A broad, flat, reflective layer that bounced the sound back almost as if it were solid ground. The operators could see it clearly on their instruments, a phantom floor, a false bottom suspended in the middle of the ocean where there should have been nothing but open water, and it would not hold still. Through the day, this false bottom would sit deep, hundreds of meters down. But as evening came and the sun set, the whole layer would begin to rise, lifting up through the water toward the surface, as though the sea floor itself were floating upward into the night. And then, before dawn, it would sink back down again, settling deep into the dark as the morning came. A bottom that climbed every night and fell every day. A sea floor that breathed. You can imagine how unsettling that must have been. These were serious people, Navy operators, scientists, men trying to use a brand new technology in the middle of a war, and their instruments were telling them that the floor of the ocean was rising and falling like a chest taking slow breaths. They gave it a careful, cautious name. They called it the deep scattering layer because it scattered their sound, bouncing the sonar pulses back in a broad, diffuse haze rather than a single, hard ring. The deep scattering layer. A phantom bottom in the middle of the sea, moving with the sun, and nobody knew what it was. The answer, when it finally came, is one of the loveliest reveals in all of ocean science. The false bottom was alive. That broad, reflective layer was not rock and not sand and not the floor of anything. It was animals, countless millions upon millions of small fish and other creatures gathered so thickly together that their massed bodies bounced the sound back like a solid surface. And the reason the false bottom rose every night and sank every day was simply this: it was the migration. It was the diel vertical migration itself, the great nightly rising and falling of life through the sea, finally showing up on a machine. The animals were climbing toward the surface at dusk, and the sonar caught them climbing. They were sinking back into the deep at dawn, and the sonar caught them sinking. The breathing seafloor was the breathing of the ocean's life, made suddenly visible in echoes to men who had no idea what they were hearing. One of the people who helped untangle the mystery was a scientist named Martin Johnson, working with others in those mid-century years to figure out what the strange scattering layer really was. And the answer they arrived at had a beautiful little detail buried inside it, a reason why these particular animals reflected sound so very well. Many of the fish in that layer carry a small pocket of gas inside their bodies, a kind of internal balloon called a swim bladder, which they use to control how they float, to keep themselves hovering steadily at the right depth without sinking or rising. That little bubble of gas is wonderfully useful for the fish, but gas reflects sound far more strongly than flesh or water does. So when a sonar pulse swept down through the sea and struck a vast cloud of fish, it was really striking a vast cloud of tiny gas bubbles, millions of little internal balloons, and every one of them threw the sound back. The massed swim bladders of countless fish, all bouncing the sonar at once, made the whole living layer shine on the instruments like a solid floor. So the phantom bottom of the wartime ocean was nothing less than the largest migration on Earth, glimpsed sideways in sound by people listening for submarines. The seafloor that breathed was the sea itself breathing, and once you know that, you can never look at a calm, flat ocean quite the same way again. Somewhere beneath it, right now, that living layer is hanging in the water, rising as the light fades, sinking as it returns, a soft, uncertain floor made entirely of life. Now, who are they, all these animals doing the climbing? Who actually makes up this living tide? At the very base of it, holding the whole great rhythm up, are creatures so small you would need to look closely even to see one, and yet so numerous that they may be among the most abundant animals on the entire planet. They are called copepods. They are tiny crustaceans, distant little cousins of the crabs and the shrimp, most of them no bigger than a grain of rice, many far smaller than that, drifting through the water in numbers beyond counting. If you scooped up a glass of seawater from almost anywhere in the world, you would likely be holding more of these little creatures than you could ever count by hand. They are everywhere. They fill the upper ocean like dust fills a sunbeam, and they are one of the most numerous kinds of animal there is. These tiny copepods are the engine of the whole migration. They are among the great climbers, rising every night to graze on the even smaller drifting plants of the surface and sinking every dawn to hide in the dark. And because there are so unimaginably many of them, and because nearly everything larger wants to eat them, where the copepods go, the rest of the ocean follows. They are the bottom rung of the ladder, the grass of the sea, and the whole nightly migration rests upon their tiny backs. A little higher up, and a little larger, come the krill. You may have heard the name, even if you have never seen one. Krill are small shrimp-like animals, a few centimeters long, pinkish and almost see-through, with large dark eyes. One kind in particular, the Antarctic krill, whose proper name is Euphausia superba, lives in the cold, rich waters around the bottom of the world, and it gathers there in numbers that almost defy belief. Antarctic krill form swarms, dense clouds of millions upon millions of bodies packed close together, swarms so vast they stain the sea and can be seen from above. Taken all together, all the Antarctic krill in all the Southern Ocean may add up to one of the largest masses of any single kind of animal anywhere on Earth. Not the largest single creatures, but the largest total weight of one species, this small pink shrimp of the cold south, gathered in its uncountable billions. And the krill migrate too. Up at night to feed, down by day to hide, riding the same dimming light, following the same ancient bargain as the copepods below them. Swarms of them, rising and sinking, a pink tide within the greater tide. And then come the hunters. Because all of this food, all these copepods and all this krill rising up through the dark, does not go unnoticed. The small fish come for the copepods and the krill. The larger fish come for the small fish. The squid come for the fish, gliding up through the black water with their long arms and their watchful eyes. Everything that eats the climbers becomes a climber itself, following its food up into the night and back down into the day. The whole food web lifts and falls together. The grazers rise to the pasture, and the hunters rise to the grazers, and the hunters of the hunters rise after them, all of them locked into the same slow vertical dance, all of them reading the same dimming light, all of them rising at dusk and sinking at dawn in one great connected breathing of the sea. Picture it the way you might picture a vast, invisible elevator running not between the floors of a building, but between the layers of the ocean, carrying its living cargo up every evening and down every morning. The smallest passengers board first, the copepods and the krill, and the larger ones follow, the fish and the squid and the things that hunt them, until the whole crowded elevator is rising together through the dark, toward the rich surface waters above. They spend the night up there in the safe black, feeding, hidden. And then, as the first grey hint of dawn touches the upper water, the elevator begins its long descent, lowering all of them back down, hundreds of meters, into the deep where the day cannot reach. Every night up, every dawn down. The largest movement of life on the planet, running on the simplest of schedules, the schedule written by the light itself. And here is the part I find most quieting of all, the part worth carrying with you down towards sleep. All of this is happening right now, not in some distant past, not as a story finished long ago, but at this very moment, somewhere on the turning earth where the sun has just gone down, the great climb is beginning again. The copepods are lifting, the krill swarms are rising in the cold, dark water. The fish are following, and the squid behind them, and the whole living layer is floating slowly upward through the black, just as it did last night, just as it will tomorrow night, just as it has on every night for longer than we can easily imagine. A breathing that never stops. A migration with no beginning and no end that we will ever see. Only the endless middle of it, turning over and over with the light. And so I want to take you down into it, slowly, gently, the way the animals themselves descend at the coming of the dawn, sinking down through the water layer by layer, away from the light and into the dark. Because the ocean is not one place. It is many places stacked one beneath the other, each one stranger and darker and stiller than the one above it. And to truly understand the migration, you have to understand the world it moves through. The lit surface where the food is grown, the fading twilight just below, the total midnight darkness deeper still, and below even that, in places so deep and so crushing and so cold that you would think nothing could possibly live there. A world that nonetheless is full of life, and full of light, and full of slow, patient motion. We are going to go down through all of it together, you and I, layer by layer. As the light dies above us, we will watch the colors disappear one by one from the water until only blue is left, and then watch even the blue fade into black. We will feel the weight of the water grow heavier with every step down. We will pass through the place where the false bottom hides by day and meet the small, glowing fish that may be the most numerous of all the creatures with backbones on the whole earth. We will sink past the hunters of the midnight dark and down through a soft and endless snow that falls forever and feeds everything below it, all the way to the very bottom of the world, where the deepest trenches plunge so far beneath the waves that a mountain could vanish inside them with room to spare. So let yourself begin to sink just a little the way you do at the edge of sleep. There is nowhere you need to be. The migration will carry on with us or without us all night long, gently, in the dark. Let your breathing slow to match it, the long, slow rise and the long, slow fall. And as the surface light begins to fade above us, let us go down softly into the first layer of the sea where the sunlight still reaches and the great green pasture of the ocean grows. For of all the strange and beautiful things the ocean does, this is the one that almost nobody sees, and it happens every single night all over the world in the dark, without an audience. The scientists who study it have a quiet, almost reverent name for it. Diel, vertical migration, they call it. Diel meaning of the day of the daily turning, the largest synchronized movement of living biomass anywhere on Earth, they say, and they mean it literally. Not the great herds crossing the plains of Africa, not the birds threading the length of the sky between the poles. Those are vast, and they are wonderful, but they are nothing beside this. Every dusk across every ocean on the planet, all at once, billions upon billions of small animals begin to climb, and every dawn, all at once, they let themselves fall back down again, a planet-sized breath, rising and sinking with the turning of the light. And it is the light that moves them. That is the gentle engine of the whole thing. These creatures do not want to be seen, and the surface during the day is a dangerous place to be seen, lit up and exposed to anything hunting from above. So they hide in the dark of the deep through the daylight hours, and only when the sun goes down and the shallows turn safe with darkness do they rise to feed. They are following the light, or rather following the absence of it, tracking a particular preferred dimness the way you might draw a blanket up to a certain comfortable height. The scientists have a word for that too, the isolume they call it, a line of brightness in the water that the animals settle along. As the day fades and that line of light sinks, the animals sink down with it through the morning. As night comes and the line rises, they rise, up at dusk, down at dawn, forever, faithfully, in the dark. For a long time, no one knew this was happening at all. The deep water was simply the deep water, dark and far away and out of mind. And then, during the Second World War, something strange began to show up on the sonar screens of ships listening into the ocean for submarines. There was a bottom where there should not have been a bottom. The sound would go down and bounce back from a solid-seeming layer hanging in the middle of the sea, hundreds of meters down, far above the real floor. A false bottom, they called it, a phantom seafloor. And the strangest part was that this false floor would not hold still. By day, it lay deep. But as evening came, it would rise, climbing slowly toward the surface through the dark hours, and then before dawn, it would sink down again into the depths and settle back where it had been. A seabed that moved with the sun. It took some careful and patient minds to understand what they were really hearing. Martin Johnson and others working in those years began to suspect the truth, and the truth was this: the false bottom was not the bottom at all. The false bottom was alive. The sound was bouncing back from countless small animals, gathered so thickly together that to the listening instruments they read as solid ground. Many of them had tiny pockets of gas inside their bodies, swim bladders the size of a grain of rice, and gas in water scatters sound beautifully, throws it back like a wall. So the war machines, listening for danger, had stumbled, without meaning to, onto one of the deepest secrets of the sea. They named what they had found the deep scattering layer, the living ceiling of the dark, and it rose every night and fell every morning, because it was made of the migration itself, of all those climbing, sinking creatures moving as one. I would love to know where in the world you are, lying in the dark, listening to this. Whether there is an ocean near you tonight, or 1,000 miles of dry land between you and the nearest wave, the migration is happening all the same, out there beyond the horizon, rising and falling while you rest. If you feel like it, leave a small note of where you are. And if these slow journeys into the deep help you find your way to sleep, you can quietly subscribe, and there will always be another waiting for you. Now, the creatures that make up this living layer, the ones that build the false floor and carry it up and down through the water every night, are mostly very small. That is worth holding on to because it is part of the wonder. The largest migration on Earth is not made of great beasts. It is made in the main of the tiniest of things. At the very base of it are the copepods. You have almost certainly never seen one, and yet they may be among the most numerous animals that have ever lived. Tiny crustaceans, smaller than a grain of rice, drifting in the upper water in numbers beyond any counting, more of them than there are stars we could ever name. They are the engine room of the whole phenomenon. They rise to graze in the dark and sink to hide in the day, and almost everything larger in the sea depends, in one way or another, on their endless multitude. And then there is the krill. In the cold green waters around Antarctica, the krill, and one kind above all, Euphausia superba, the Antarctic krill, gather in swarms so dense and so enormous that they form one of the single largest masses of any one creature anywhere on the planet. Picture a cloud of them in the water, reddish and shimmering, stretching further than you could swim in a day, each one no longer than your little finger, and all of them together weighing more than almost any other animal you could name. They too ride the nightly elevator, up into the dark to feed, down again before the light returns. And they are the great table around which the whole Southern Ocean gathers to eat. The whales come for the krill. The seals come for the krill. The penguins, the fish, the seabirds, all of them are there for that drifting reddish multitude that climbs and falls with the turning of the day, because that is the other half of it. Where the small things go, the larger things follow. The migration is not only the copepods and the krill and the small glowing fish, it is everything that hunts them, drawn upward in their wake and sinking back down behind them. The predatory fish that feed on the swarms rise to feed in the dark shallows and retreat to the depths by day, shadowing their prey. The squid do the same, moving up through the layers at night to hunt, slipping back down before the light. Layer upon layer of the ocean lifts and settles as one, the eaters following the eaten, a whole moving architecture of hunger and hiding, sliding up and down through the water column twice a day, every day, since long before there was anyone to watch it. So that is where we are going, you and I. Down into that moving dark. We will start in the green pasture at the top, where the light still reaches and the small things gather to graze. And then we will go down, slowly, following the long, slow fall of the dawn descent, down past the place where the false floor hides by day, down through the fading blue and into the black beneath it. We will go gently the way the krill go, the way the small, glowing fish go, the way the whole patient migration goes, in no hurry at all, with nowhere it needs to be by any particular time. Let the rhythm of it carry you. The long, slow rise, the long, slow fall. Breathe with the ocean and let us begin to sink together down out of the last of the light into the great twilight that waits just below. The sunlight zone begins at the surface and reaches, if the water is clear and the sky is bright, to a depth of roughly 200 meters. 200 meter height, which sounds like a great distance when you say it plainly, and yet is almost nothing when set against the full column of the ocean beneath it. That thin upper skin, that well-lit upper room, is where all the sunlit work of the ocean happens. The photosynthesis, the growing, the dense, pulsing meadows of phytoplankton converting light into life. Everything below 200 meters lives in some way or another on what this thin, bright layer produces. And right now, as the long, slow descent of evening draws on, something extraordinary is rising through it, coming up from below to harvest what the light has made. But before we sink, it is worth pausing for a moment in the light itself, to see what the light is and to understand what happens to it as you go down, because it does not last. Stand at the surface of the open ocean on a clear afternoon, and the water beneath you looks blue. Not one blue exactly, but a shifting, layered, sunlit blue that goes deeper as your eye travels down, fading from turquoise near the surface to something darker, denser, more mysterious beneath. You can see perhaps a few tens of meters before the light gives out, and the blue becomes merely darkness. But that is looking from above. If you were to descend yourself, if you were to slip beneath the surface and begin slowly to sink, you would notice something almost immediately that no description quite prepares you for. The colors are dying, not all at once, not all together. They die in sequence, one by one, as if someone far above is turning off the lights by wavelength, most fragile first. Red is the first to go. Sunlight, as it reaches us across empty space, carries all the colors of the visible spectrum. And among them, red light carries the least energy and is absorbed most readily by water. By the time you have sunk to around 10 or 15 meters, the red is already gone, not dimmed, not softened, gone. If you were to hold out your hand at 15 meters deep and your hand were bleeding, the blood would not appear red. It would appear dark, almost black. The ocean has already swallowed that particular wavelength, filtered it out of the world below with a thoroughness that strikes most people as slightly uncanny the first time they encounter it. Keep going down, and orange follows, then yellow, then more slowly green, each one absorbed into the water, converted to heat, scattered and lost. The visual world at 50 meters is already a stripped-down place, a blue world, a world of shadows and diffuse illumination, with nothing left of the warmth and variety of the surface light. At 200 meters on a clear day in clear water, there is still a faint blue presence. Not enough to read by, barely enough to perceive. A kind of deep-sea dusk that has lasted since morning and will last until midnight, unchanging, a permanent twilight that tells you almost nothing about what time it is above. And below that, there is nothing. No sunlight at all, not a photon. The ocean at 1,000 meters is in a darkness that makes a cloudless, moonless night on land seem bright by comparison. It is a darkness that human eyes, however well adapted, cannot penetrate. A darkness that has no bottom, no wall, no reference point, that extends in every direction with an impartiality that the word dark barely begins to capture. It is the most abundant kind of darkness on Earth because the deep ocean is the most abundant kind of place, and it is almost entirely, utterly without light. But here is what changes everything. When the sunlight dies, something else begins. The light does not vanish from the deep ocean, it merely changes its origin. We are still, for the moment, in the twilight zone, the mesopelagic, the layer that runs from 200 meters to roughly 1,000. The layer where the diel vertical migration goes to sleep in the daytime, because this is where the deep scattering layer hides by day. That vast, acoustically reflective congregation of fish and siphonophores and shrimp and squid pressed down into the fading blue, sheltering from the predators of the bright water above. They are here now, all around, distributed through millions of cubic kilometers of dim ocean, waiting for the light above to fail again so they can begin their ascent. And here, already, the light is alive, not sunlight. Something older, stranger, and produced at a metabolic cost that every creature carrying it has decided is worth paying. Bioluminescence. The making of light from chemistry, with no flame, no heat, no waste. A cold light produced in specialized organs called photophores, or in the fluid of a living cell, or in colonies of bacteria sheltered inside another creature's body. In the mesopelagic zone, bioluminescence is not a curiosity or a rarity. It is close to being the standard condition. A study conducted off the coast of Monterey, California, in the well-examined waters off the Monterey Bay Aquarium Research Institute, found that roughly 3 in 4 of the animals observed in the midwater column were bioluminescent. 3 in 4, not 3 in 100, not 3 in 10, 3 in 4. Which means that if you were to sink through the twilight zone in a vessel with the lights off, and if you were to watch the water around you with your eyes adjusted to the deep dark, you would not be watching a sparse constellation of occasional glows. You would be surrounded by light. Moving light, patterned light, light that flashes and pulses and streams and lingers, light produced by creatures going about their daily life, or rather their nightly lives, their daytime resting lives, in the dim water all around you. And among the brightest, the most numerous, the most astonishing producers of this living light are the lanternfishes, Mactophidae. The family name, from the Greek for lamp and fish, tells you exactly what you need to know about them in a single compound word. Lampfish, fish made of lamps. They are small. Most species are only a few centimeters long, about the size of a finger, sometimes smaller, with large eyes evolved to gather as much of the dim residual light as possible, and along their bellies and flanks arranged in patterns that are precisely specific to each species, rows upon rows of photophores, light organs, each one a small window of living chemistry capable of producing a controlled, directed glow that serves purposes the fish has been refining over evolutionary time far longer than our species has existed. The patterns of photophores on a lanternfish are not decorative, they are identification. In the dim blue twilight of the mesopelagic, where color has largely vanished and the world is measured in shades of darkness, the arrangement of lights on a fish's body is the equivalent of a face, a signature, a species marker, a signal that allows a lanternfish to recognize another of its own kind in a darkness where visual detail has almost entirely disappeared. Different species carry their lights in different configurations, as distinctive as a fingerprint, as readable in the right light as a name tag. And there are a great many lanternfishes to identify. The family Mectophidae contains something like 250 species distributed across every ocean on Earth, and in total they represent what may be among the most abundant vertebrates on the planet. Not the most famous, not the most studied, in the way that a whale or a tuna is studied, but by sheer weight and number one of the dominant vertebrate groups in the biosphere. A paper published in 2014 drawing on data from the Malaspina expedition, a Spanish scientific circumnavigation that crossed the Atlantic and Indian and Pacific Oceans and sampled the mesopelagic waters systematically, suggested that the total biomass of fish in the open ocean mesopelagic zone might be on the order of 10 billion tons. 10 billion tons, which is something on the order of 10 times higher than the estimates that had been accepted until recently. The reason the old estimates were so far off is partly the same reason the deep scattering layer confused sonar operators during the war. These fish are very good at not being where you look for them. Standard trawl nets, hauled through the midwater at night, catch them. But trawl nets miss a large portion of the most agile animals, which swim around or below the net as it descends. Acoustic surveys, counting the reflections of sound off the gas-filled swim bladders of the fish themselves, the same mechanism that created the wartime false floor, suggest the numbers are vastly larger than nets alone would indicate. 10 billion tons of living fish riding up to the surface each night and back down each dawn, a mass so large, distributed so widely and so thinly across the ocean that it passes beneath the world's shipping lanes and fishing fleets and oceanographic vessels without most of us ever registering that it is there. This is the hidden majority of the ocean's vertebrate life, not the whales and the dolphins and the tuna we know, the lanternfishes and their mesopelagic companions, the bristlemouths, the hatchetfishes, the small squid and shrimp, making their patient daily commute between the surface and the deep, glowing in the twilight, eating and being eaten, and collectively moving a quantity of carbon from the upper ocean into the deep that has genuine, measurable consequences for the chemistry of the planet. But we were talking about the light, and specifically about what happens to the light as you go deeper, and why the animals of the deep look the way they do. Red, we said, disappears by 15 meters. And in a world without red light, something interesting happens to a red-colored animal. It disappears. This is a piece of physics that the ocean has turned into a biological strategy. Red light at depth does not exist. There is no red illumination to fall on a red surface and bounce back to a watching eye. So a creature that is red, a deep red, the dark crimson of a lanternfish's belly, or the vivid scarlet of a certain shrimp, is functionally invisible in the same way a black cat is invisible in a dark room. Not because it is hiding in a shadow, because the light required to reveal its color does not exist at that depth. The animal is present, physically present, perfectly real. But to any predator looking for it in the blue dim twilight, it registers as nothing, as dark water, as absence. Many mesopelagic and deep-sea animals are red for exactly this reason. The shrimp, certain jellyfish, the deep-sea dragonfish. Creatures whose red pigmentation at the surface in full sunlight would make them conspicuous as a warning flag, wear the same color at depth and become essentially invisible. The ocean below 15 meters has no red light. To live there in red is to live in a kind of permanent camouflage, to carry the color of invisibility. And bioluminescence, the living light, is blue. Not always, not universally. There are exceptions, some extraordinary ones we will come to. But overwhelmingly, the light that living things produce in the ocean is blue, or blue-green. The peak wavelengths cluster around 460 to 500 nanometers, a color that human eyes perceive as a clear, cold, slightly electric blue-green. The same color that penetrates water most deeply, the same color that a predator looking upward through hundreds of meters of water would see as the background glow of distant daylight. This alignment is not coincidence. Counter-illumination is one of the more elegant inventions of mesopelagic life, and when you understand how it works, it takes a moment to simply sit with the ingenuity of it. Any animal swimming through even the faint residual light of the twilight zone casts a shadow downward. Not a sharp shadow. There is no sharp light source here, only diffuse illumination from above, but a silhouette, a darker shape against the dimly lit water column above it, visible from below as a patch of reduced brightness. And any predator hunting from below, looking upward toward the surface, would use exactly that silhouette to find its prey. The mesopelagic animals that have solved this problem produce their own light on their ventral surfaces, their bellies, the sides that face downward. They produce it at the precise brightness and color to match the ambient downwelling light around them, so that from below they have no shadow. Looking upward through the water at a hatchetfish, one of the silver, laterally compressed little fish that populate the twilight zone, named for the shape of their bodies, you would not see a silhouette. You would see light that matches the water around it. You would see effectively nothing where the fish is. The fish has erased itself from the view of anything looking up. Hatchetfishes do this, lanternfishes do this. The Hawaiian bobtail squid, a small, jewel-like cephalopod that lives in shallower waters and was among the first animals to have its counter-illumination studied in detail, achieves the same effect using bioluminescent bacteria housed in a light organ on its mantle. The bacteria produce the light. The squid adjusts the brightness with a shutter of muscle and pigment. The match to ambient light is tuned throughout the day as conditions change. The squid carries its own invisible cloak maintained by the collective photon production of billions of living microorganisms living inside it. In the twilight zone, counter-illumination is not rare, it is common. It is one of the standard tools of survival in a place where the light comes from one direction and the predators come from every other. And yet the light above, the trigger for all of this, the reason the migration rises and falls, the force that the isolume-following animals of the deep are constantly tracking, is itself not simple. It does not merely switch on and off, day and night, sun and dark. It has finer rhythms than that, the moon, for instance. Diel vertical migration tracks a preferred light level. An isolume, a surface of equal light intensity that moves up and down through the water column as the sky above brightens and dims. The animals do not simply rise at night and sink by day in a binary toggle. They track. They follow the brightness down as morning comes, keeping themselves in a zone where the light is dim enough to be safe. And they follow it back up as evening comes, riding the isolume toward the surface. What they are tracking is relative brightness, and that relative brightness changes not only with the sun, but with the moon. On a bright, full moon night, the surface of the ocean is measurably illuminated. Not daylight, nothing close, but enough that the animals sensitive to light in ways that exceed our own sensitivity, perceive it. And so on the brightest moonlit nights, many migrators descend a little deeper. Not all the way back to their daytime depths, but deeper than on a dark, cloudy, moonless night. The moon, waxing and waning through its monthly cycle, introduces a slower rhythm into the daily rhythm of the migration. A rhythm riding on top of a rhythm, a long wave beneath the shorter one, shifting the depths of the evening congregation through the lunar month in a slow oscillation that oceanographers studying the deep scattering layer can measure in acoustic data. This lunar influence on the migration, and lunar vertical migration in the technical literature, is one of the subtler and more beautiful aspects of the whole phenomenon. The ocean's life in the dark is listening to the moon, and there is a place on Earth where it listens to the moon for months on end because the sun itself has gone away. The Arctic, in winter, does not have a night in the usual sense. It has a polar night, a night that lasts for weeks or months, during which the sun never rises above the horizon and the sky above the ice is lit only by stars, the aurora, and the moon cycling through its phases. The question of what happens to diel vertical migration during the polar night is one that oceanographers began asking seriously only relatively recently, and the answer they found surprised many of them. The migration continues in the polar seas in the depths of winter when there has been no true sunlight for weeks. The zooplankton, copepods and krill and amphipods still perform a rhythm of ascent and descent, not driven by the sun, which is absent, driven by the moon, by the extremely faint light changes associated with the lunar cycle and with the dim, distant glimmer of civil twilight when the sun lies just below the southern horizon. Changes in light so subtle that were you standing on the ice above, you might not perceive them at all. The animals below evolved over millions of years to track exactly these gradients, track them still. They ride up toward the faint light of the full moon and sink from it as it wanes. They maintain their rhythm in the dark, the way a clock keeps time in an unlit room, the mechanism working, the pendulum swinging, the hours counting, even when no one is there to read the dial. It is one of those facts about the natural world that once you know it, changes how you feel about cold and darkness and the absence of the sun. Something is moving still in the dark water under the winter Arctic ice. Something is listening to the faint light of the moon and rising toward it and retreating from it, the same as it has always done, the same as it does in every ocean at every latitude, patient and perpetual, and entirely indifferent to the fact that no one is watching. We are sinking further. The light above is still visible if you tilt your instruments upward, a dim blue ceiling far away, growing dimmer. Below, the light grows with you, not from the sky, but from the water itself, from the siphonophores and the bacteria and the glowing cells of the creatures all around. You are, in this moment, inside the deep scattering layer, the false floor, the thing the sonar found in the war and could not explain. You are inside the layer of millions upon millions of fish and squid and shrimp, each carrying their own small light, distributed through a volume of water so vast that its edges in most directions are beyond any instrument to precisely locate. And you can sense, if you pay attention to the way the pressure registers in the body, the way it begins subtly to change, that you are approaching the lower boundary of the twilight zone. The mesopelagic ends at roughly 1,000 meters. Below that, another kind of dark begins. A darker dark. The zone that has never, not once in its existence, received a single photon of sunlight. But that is a step we are not yet ready to take. There is still something to notice here at the edge of the twilight, something drifting past you, barely visible even against the dim glow of the surrounding bioluminescence, something so quiet and so constant that it would be easy to mistake it for a trick of the light. It is not a trick, it is falling. It has been falling since before you began to watch, and it will continue to fall long after you have gone. It falls at every depth, through every zone, from the bright surface all the way to the deepest trench. A slow, silent, continuous rain of particles, each one so small and so light that it takes not hours but days, sometimes weeks, to make the full journey from the surface to the bottom. Oceanographers call it marine snow, and the name is one of those rare technical metaphors that does not exaggerate at all. It is snow. It falls through water the way snow falls through air, gently, drifting, catching what faint light there is and throwing it back in tiny, scattered flickers before vanishing again into the dark below. What is it made of? Everything, more or less, that once lived in the upper ocean and no longer does. The shells of diatoms, microscopic algae with intricate silica housings the size of a grain of dust. The shed molts of copepods, the exoskeletal casings they leave behind each time they grow, fecal pellets compacted and dense, sinking faster than loose particles, mucus aggregates, the stringy, transparent webs secreted by certain zooplankton and by filter-feeding animals, which collect smaller particles and bind them together into larger, faster-sinking lumps, bacteria clinging to every surface, consuming and being consumed, dust blown from the continents and settling into the sea, the accumulated waste and death of the sunlit world above, all of it falling, falling, falling. This is what feeds the dark, not sunlight. Sunlight never arrives here. Not photosynthesis. There is nothing to photosynthesize with. The dark ocean, from the base of the twilight zone all the way to the trenches at the bottom of the world, is fed almost entirely by what drifts down from above. The marine snow is the supply line, the only supply line, from the productive surface to the vast uninhabited blackness below. And everything that lives at depth, from the midwater fish to the bacteria in the sediment on the hadal floor, depends on it in one way or another. To live in the deep is to live downstream of the sun, at the end of a long chain of transfers and transformations that begins with light striking water at the surface and ends thousands of meters and many weeks later with a scrap of organic matter settling onto mud no human eye has ever seen. And there is something worth pausing to notice about this, something that ties the falling snow to the rising migration in a way that makes the whole picture more coherent. The diel vertical migration and the marine snow are not separate phenomena. They are part of the same cycle. When the lanternfishes and the copepods and the krill rise to the surface at night, they eat. They feed in the rich, productive, phytoplankton-dense upper ocean, consuming carbon that was fixed from the atmosphere by photosynthesis. When they sink back down at dawn, carrying their full stomachs into the deep water, where the temperature is low and the pressure is rising, and the predator pressure from visual hunters is absent, they metabolize that carbon in the deep. They respire it away at depth. They excrete it at depth. Their fecal pellets, dense and fast-sinking, carry surface carbon into the deep. When they are eaten by the predators that follow them down, that carbon passes into larger bodies that live primarily at depth. The result is a daily mass transfer of surface carbon into the deep ocean, the part of the biological carbon pump driven not by the passive sinking of marine snow, but by the active swimming of billions of animals, by their own bodies carrying the products of sunlit productivity into the dark and releasing it there instead of at the surface, where it would quickly return to the atmosphere. The migration is, among its other identities, a carbon transport mechanism of global consequence, a living conveyor belt running between the surface and the deep, twice a day, year-round, carrying the ocean's chemistry in its muscles. It is a thought worth holding for a moment. The largest migration on Earth is also part of the machinery that regulates the carbon content of the atmosphere. The small glowing fish and the copepods and the krill are not merely remarkable. They are part of the mechanism that makes the surface of this planet habitable. The lanternfish, riding up in the dark, carries more than its own body. And with that weight of understanding, we are ready to go deeper. The light above is barely visible now. A faint blue ceiling, impossibly remote, growing dimmer by the second as we sink. The photophores around us are the only constant light, small, blue-green, moving, appearing and vanishing as the animals carrying them angle through the water in every direction. The marine snow continues to fall past us, patient and silent. The pressure is building, 1 atmosphere for every 10 meters, which at 200 or 300 meters means we have added 20 or 30 atmospheres to the one we started with, a compression so gradual that the body barely registers it, the way you rarely notice the weight of the air above you at sea level until someone reminds you that it is there. We are still in the twilight zone, but the lower edge is close. The mesopelagic will give way somewhere around 1,000 meters to the bathypelagic. The midnight zone, the zone that takes its name from the hour at which even the latest lover of the dark has finally given up on the sky. The zone where the last trace of sunlight has not merely faded, but has ceased to exist as a physical phenomenon, where the water above transmits no photon from the sky, no matter how long you wait or how sensitive your instrument. The zone that is dark in a way that is not merely the absence of light, but the structural impossibility of light, where the water column above is thick enough and the absorption complete enough that the sun above might as well not exist. We are about to cross that line. But before we do, notice one last time the scene around us in the upper twilight. The hatchet fishes with their silvered sides and their counter-illuminating bellies erasing their own silhouettes for any predator below. The lanternfishes, rows of photophores glowing cold and steady along their flanks, reading each other's light patterns in the dimness. The copepods, countless as dust, moving in their patient spiraling paths through the water. The marine snow falling. Everything here is lit. Not brightly, not warmly, not the way the surface is lit by the broad, generous scatter of noon sunlight through a clear sky, but lit, alive with the cold fire of organisms who have taken the chemistry of luciferin and luciferase and turned it into something that serves them, that finds them mates and confuses their predators and erases their shadows and calls for help. 3 and 4 of them glow. 3 and 4 of the animals surrounding us in this dimming water are carrying their own light. We are inside a cloud of living stars, sinking slowly through them, and they are barely aware of us, and the migration is still moving. Still rising at this hour of the night, the copepods still climbing toward the surface pasture far above, the lanternfishes following, the whole great tide of biomass sweeping upward past us even as we descend. And below us, 1,000 meters down, something altogether different waits. Something that has never once seen the sun. Something that was never part of the daily migration, that does not rise and does not fall on the schedule of the light above, that lives in the only perpetual night this planet offers and has adapted to it in ways that make even the twilight zone, with its bioluminescent three-quarters and its counter-illuminating hatchet fishes, seem almost familiar by comparison. The midnight zone, the bathypelagic, below us and growing closer. We are going there now. The boundary is not a wall. It does not announce itself with any physical sensation you could describe, any dramatic change in the texture of the water or the temperature of the current. It is a threshold you cross. The way you cross into sleep itself, gradually and then completely. One moment there is still the faintest suggestion of light from above, a blue so dark and residual it is closer to the memory of light than light itself. And then there is not. 1,000 meters below the surface of the ocean, the sun ceases to exist. Not dims, not fades to the last faint blue it managed at 900 meters. Ceases. There is no photon from the star that warms this planet that has ever reached where we are now. The sunlight zone, with its photosynthesis and its chlorophyll and its surface pastures, is a full kilometer above us. The twilight zone, with its 3 in 4 glowing animals and its counter-illuminating hatchet fishes and its copepods spiraling patiently upward through the dark, is above us too now. We have left it. We have crossed, without ceremony, into the bathypelagic zone, the region oceanographers call the midnight zone because midnight is what it is, permanently, without variation, world without end. And the first thing you notice once you accept the dark is that the dark is not empty. It is snowing. Not cold snow, not fast snow. The particles that drift past us here are so small and so slow that calling them snow at all is almost misleading. And yet snow is exactly the right word, because the motion is the motion of snow on a windless night, that unhurried, that peaceful, that continuous. These particles are marine snow, and they have been falling here, in this water column, every hour of every day for as long as this ocean has existed, and they will go on falling long after every human civilization on the surface has finished its brief and noisy business and gone quiet again. Marine snow is made of the dead, or rather, it is made of what the living leave behind. Dead plankton, their cell walls broken, drifting down from the sunlit zone where they bloomed and photosynthesized and died. Fecal pellets, the compressed, dense waste products of copepods and krill that have been feeding at the surface all night, which sink faster than loose particles because the animals produce them dense and packaged, a strange and accidental gift to the deep. Mucus, sheets and strands of it, secreted by organisms as feeding structures or defensive coverings, sloughing off into the water when the animal molts or dies or simply lets it go. Dust from the continents, blown off the land by wind and carried out over the ocean and settling at last when it can no longer be held aloft. The aggregated, clumped remnants of diatoms and foraminifera, the microscopic architects of the surface world, their tiny glass and chalk shells sinking when their bodies have been consumed and there is nothing left to hold them up. All of it drifting down. A single particle of marine snow might take 2 weeks to travel from the surface where it formed to the seafloor where it will finally rest. 2 weeks of falling through 1,000 meters of twilight, through the boundary we just crossed, through the midnight zone, through the abyss below that, all the way to the bottom. 2 weeks of being jostled by passing currents, of being intercepted and eaten and excreted in new form by organisms on the way down, of aggregating with other particles into larger, denser clumps that fall a little faster, or being broken apart by turbulence into smaller pieces that will drift for longer still. And this is what everything down here lives on. Think about that for a moment. Sit with what that means. You are in the largest habitable space on Earth. The deep ocean represents the overwhelming majority of the livable volume of this planet, the vast, dark interior of a world that is mostly ocean, and the ocean is mostly deep, and the entirety of that space is fed by this soft, slow, continuous drizzle of the dead falling from the world above. There is no photosynthesis here. There is no plant matter, no algae, no sunlight to power the base of a food chain. Everything that lives in the midnight zone, in the abyss, At the bottom of the trenches, everything is connected by this chain of falling particles to the surface, to the sun, to the pasture far above where the copepods graze. The deep is not separate from the world above, it is downstream from it. Every creature that has ever lived and died in the sunlit ocean has contributed in some small measure to the snow that feeds the dark. The water here is cold, cold in a way that is constant and total, not the variable cold of a surface ocean that warms in summer and chills in winter, but a steady, unwavering cold of about 2 to 4 degrees Celsius, just above freezing, just above the point where water becomes ice, held at that temperature by the enormous insulating weight of the water above and the near-total isolation from the sun. It has been this temperature in these deep regions for a very long time. The midnight zone is perhaps the most stable habitat on Earth in terms of temperature and pressure. Unchanging across seasons, barely changing across centuries, a dark and constant world that does not know the urgency of the surface, does not know day or night, does not know the turn of seasons and the pressure. We have been sinking since we began, and the pressure has been climbing the entire time. 1 additional atmosphere for every 10 meters of descent, regular as a clock, building and building until here, at 1,000 meters, we are under roughly 100 atmospheres. 100 times the pressure that the air exerts on your body as you lie in bed tonight. 100 times the weight of the atmosphere pressing in from all directions simultaneously, not from above only, but from every side, a uniform crushing that a human body in its ordinary state could not survive for a moment. The animals here do not notice it. They have been shaped by it over millions of years of evolution, their bodies designed around it the way your body is designed around the single atmosphere you have never once thought about. Their cells are filled with water, which does not compress, and the proteins and membranes that do the work of their biology have been tuned through the slow, patient process of natural selection to function correctly under this weight. Some of them carry special molecules specifically to stabilize their proteins against the crushing that would otherwise deform them and render them useless. The pressure is not a problem for them. It is simply the condition of existence. But it means that they live slowly. In the midnight zone, with its cold and its dark and its thin rain of calories from above, the metabolic pace of life is measured and careful. Animals here move as little as possible. They wait. They drift. When food comes to them, a piece of marine snow, a fragment of something larger, a rare piece of luck in the form of a larger animal that has wandered into range, they take it. When food does not come, they wait. Their hearts beat slowly. Their growth is slow. They live long by the standards of comparably sized creatures in the world above, because they must husband every calorie that arrives, spending as little as possible on the simple maintenance of being alive so that there is something left over, occasionally, for reproduction, for growth. The deep is patient in a way that the surface, with its urgency and its blooms and its frantic upward and downward migrations, is not. And yet it is not quiet exactly, not motionless, because there are hunters here. The sperm whale does not live in the midnight zone. Its blood is warm, its lungs require air, and the surface of the ocean is where it breathes, where it is born, where it will die. But the sperm whale descends into the midnight zone every single day of its adult life to hunt, and in doing so it becomes briefly a creature of 2 worlds. A warm-blooded, air-breathing mammal penetrating a cold, dark pressure environment that should, by any ordinary logic, be inaccessible to it. Physeter macrocephalus, the largest toothed predator that has ever existed on this planet, a creature whose head can account for 1/3 of its total body length, and whose head is largely filled, in the upper portion, with a vast reservoir of waxy oil called spermaceti, the material that gave the whale its name when whalers first rendered it and found it looked to them like something it was not. The function of the spermaceti organ is still not entirely resolved, but current thinking suggests it plays a role in focusing and projecting sound in the echolocation system that is the sperm whale's primary sense in the dark, because in the midnight zone, the sperm whale cannot see. Its eyes, large as they are useless here. There is nothing to see, there is no light except the occasional cold blue flash of a bioluminescent organism, and those flashes are infrequent and dim and scattered. The whale navigates, hunts, and presumably perceives its entire world through sound, through the clicks it produces at enormous volume, clicks that travel outward through the water and return as echoes from everything they strike, and from which the whale's brain constructs in real time a three-dimensional acoustic map of the dark around it. It can hear a squid at distance in the dark. The sperm whale dives to roughly 1,000 to 2,000 meters on a typical hunting dive, well into the midnight zone, into the permanent darkness, into the cold and the pressure. It holds its breath for an hour or more. Its heart rate slows dramatically on the dive, a response called the diving reflex that conserves oxygen by restricting circulation to the organs that need it most and letting the extremities cool and slow. Its muscles are packed with myoglobin, a protein that stores oxygen directly in the tissue, turning the muscle a dark, reddish-brown that is the color of meat that has been selected over millions of years for the single purpose of holding air deep underwater. And it goes down alone in the dark, clicking, listening. What it is hunting is the colossal squid. Mesonychoteuthis hamiltoni, the colossal squid, is not well known because it is rarely seen. It lives in the deep ocean of the southern hemisphere, primarily around Antarctica, at depths that humans have almost never directly visited. Most of what we know about it comes from incomplete specimens, from the stomach contents of sperm whales, from animals that have washed ashore or been brought up accidentally by deep-sea fishing gear, from a handful of encounters that have been documented with cameras. It is real, it is very large, and it has eyes. Its eyes are approximately 27 centimeters across, the size of a dinner plate. The largest eyes of any animal known to science, not just any living animal, but any animal ever recorded. Eyes that large are not needed to see in ordinary conditions. Eyes that large are an extreme adaptation to a specific problem, the problem of detecting a very dim, very distant, very important light source in an otherwise lightless environment. The eyes of the colossal squid are thought to be specifically tuned to one task above all others, detecting the bioluminescent glow that a sperm whale produces as it approaches through the dark. A sperm whale hunting in the midnight zone generates bioluminescent disturbance. As its huge body moves through the water, it disrupts the organisms around it, and those organisms, many of them, 3 in 4 of the creatures in the mesopelagic, bioluminescent, flash and glow in response to the disturbance. The whale is large enough, moving fast enough, that its approach through a region of bioluminescent plankton creates what amounts to a dim, moving glow, a faint announcement of something enormous coming through the dark. The colossal squid's dinner plate eyes are calibrated to catch that announcement from as far away as possible, to see the whale before the whale can hear the squid, because if the whale gets within sonar range first, the squid may not survive the encounter. The eyes are not for hunting, the eyes are for fleeing. They are the squid's only early warning system in a world where there is no other light. And lower in the same dark water, at every depth from the mesopelagic down through the midnight zone and into the abyss, there are others. Creatures adapted to the dark in ways that are harder to describe because they solve problems we did not know existed until we found the animals that needed to solve them. the anglerfish. There are many species of anglerfish scattered across different genera and families, and they do not all look the same and they do not all share every trait, but the deep-sea anglerfishes of the order Lanternfish are the ones most people think of when they hear the name, those dark, bulbous, fang-mouthed creatures with the glowing lure dangling from a modified fin spine, extended above and in front of their mouths, bobbing gently in the current like a lantern hung above a dark doorway. The lure is called the esker. It glows because it contains bacteria, bioluminescent bacteria living in symbiosis with the fish, housed in a specialized organ, fed by the fish's body, producing their light continuously as long as they are alive and well. The light they produce is cold and blue, like nearly all bioluminescence in the deep ocean, and it pulses or flickers in ways that the fish can control to some extent, making it more attractive, more convincing, more like the small organisms a hungry fish in the dark might be drawn toward. It is a trap. It is a lure held out in a dark place where things that move toward light are things that have been selected for moving toward light, because in the deep ocean, light often means food, means the bioluminescence of edible organisms, means something worth investigating. The anglerfish hangs nearly motionless in the dark water, spending as few calories as possible on simple existence, and waits for something to come to its light. When something does, its mouth opens. The mouth of a deep-sea anglerfish is, relative to its body, enormous, disproportionate in a way that looks almost wrong, as if the fish is mostly mouth with a body attached as an afterthought. Its teeth are long and curved inward, so that anything that passes them going in has great difficulty passing them going out. It can expand its stomach to swallow prey considerably larger than itself, a necessary adaptation in an environment where food is rare and the opportunity to eat must be fully exploited when it arrives. But there is another problem that the anglerfish faces in the midnight zone, one that the lure solves only for feeding, not for the other fundamental requirement of any creature that wishes to leave descendants. In the deep ocean, in the dark, across the vast three-dimensional emptiness of the water column, finding a mate is extraordinarily difficult. The deep is not like a forest or a savanna or even the surface ocean, where animals move within a relatively thin layer, and encounters between members of the same species happen with some regularity. The midnight zone is 3,000 meters thick. It covers most of the surface area of the Earth. The density of any given species within it is low, not because the species is rare necessarily, but because the volume is so vast that even a numerous species is spread thinly through it, and the probability of any given individual encountering another individual of the opposite sex at the right moment, in the right condition, is genuinely, profoundly low. The male anglerfish solves this problem in a way that, when it was first described, was so strange that the scientist who found it did not believe it was a real species. The male is much smaller than the female, dramatically smaller, in some species the size of a thumb compared to the female's fist. When the male hatches, it has well-developed eyes and a good sense of smell, and it uses both of these to find a female. It can smell her pheromones in the water from a considerable distance, and it follows that scent through the dark, and when it finds her, it bites into her skin and does not let go. At first, this seems like a prelude to something ordinary. It is not. The male's body begins to fuse with the female's. Its mouth, pressed against her skin, starts to merge with her tissue. The blood vessels of the two animals connect. Over time, the male's eyes degenerate. They are no longer useful. He has found what he was looking for. His internal organs degenerate. His own immune system, which would normally reject the foreign tissue of another individual, is suppressed or overridden. He becomes, over weeks and months, not a separate animal pressing against the female's body, but a part of her body, a permanently attached appendage connected to her circulatory system, sharing her bloodstream, deriving all his nutrition from her. What remains of him are the gonads, that is all. When she is ready to reproduce, he provides what is needed. She continues to feed, to grow, to hunt by lamplight in the dark. He continues to be part of her, without eyes, without independent digestion, without a separate life. A female anglerfish can carry multiple males. She does not choose to. It is simply the consequence of her body being the thing that males are built to find and fuse with. She is a moving system for reproduction, and they are components of that system, and the darkness and the distance and the loneliness of the midnight zone are the conditions that made this extraordinary arrangement the one that worked. Not far from where the anglerfish drifts, waiting with its lantern, there moves another animal entirely, one that resolves the darkness not by attracting prey to light, but by weaponizing light in a completely different way. The Atolla jellyfish. It is a small animal as jellyfish go, a few centimeters across, red-colored, which means it is effectively invisible in the midnight zone, just as the red-colored deep-sea shrimp and red-colored fish are invisible. There is no red light here to illuminate a red body, and so red functions as a form of camouflage, a way of being present without being seen. The Atolla goes about its life in the dark, largely undetected, eating what it can and being eaten by what it cannot escape. But when something grabs it, when a predator takes hold of it and begins to consume it, the Atolla does something remarkable. It produces light, not a steady glow, not the quiet bioluminescence of counter-illumination or the patient pulse of an anglerfish's esker. It produces a spinning wheel of blue light that rotates around its body, a rapid, dramatic display of bioluminescent flashing that radiates outward in pulses from the point where it is being grabbed, a spectacle of light in the dark that has no purpose, as far as the Atolla is concerned, of attracting anything to itself. The Atolla cannot eat the light. The light does not repel the predator that has seized it. The light is a call for help directed at something bigger. This is sometimes called the burglar alarm hypothesis, and it works like this. The Atolla, being eaten by a mid-sized predator, produces a brilliant visual display. That display in the dark water of the midnight zone is visible from a considerable distance. It attracts the attention of whatever larger predator is in the vicinity, something that might itself want to eat whatever is eating the Atolla. If the larger predator responds, it attacks the animal attacking the Atolla. In the confusion, the Atolla may escape. The Atolla has effectively sent up a flare. It has turned its own capture into a signal. It has decided, or rather been shaped by evolution, to behave as though it has decided that the best response to being eaten is to call for something even more dangerous to come and complicate the situation. It is not guaranteed to work. Nothing in the midnight zone is guaranteed to work. But it works often enough that the behavior has been maintained across generations, that the capacity to produce that spinning wheel of blue light in extremity has been selected for, preserved, passed on, refined. The Atolla carries it always and uses it rarely, and the dark waters of the midnight zone carry its signal outward in those rare moments, and something sometimes responds. All of this, the anglerfish's lamp, the Atolla's alarm, the squid's dinner plate eyes watching for the glow of the approaching whale, all of it is possible only because of the dark. And the dark, in the midnight zone, is made deeper by something happening above and far above, something we have been tracking since the beginning of this journey, the migration. During the day, the mesopelagic twilight zone fills with animals that came down from the surface at dawn, hiding from the visual predators of the sunlit world. Those animals, the copepods and the krill and the lanternfishes with their photophores, are resting at depth, metabolizing quietly, waiting for dusk to rise again. While they are there, they are doing something beyond resting. They are breathing, they are excreting. They are taking the carbon they absorbed from their surface feeding, the carbon that passed through the phytoplankton, through their own digestive processes, into their bodies, and they are releasing some of it at depth in forms that will not return to the surface quickly. Some of it goes into the water as dissolved carbon dioxide, exhaled at 1,000 meters instead of at the surface, injected deep enough that the circulation patterns of the ocean will take years or decades to bring it back to where it could exchange with the atmosphere. Some of it goes into fecal pellets, those dense packages of compressed organic material that sink more quickly than loose particles, carrying the surface-derived carbon downward faster than it would travel on its own. Every night, billions of animals carry a small amount of carbon from the surface to the deep, and every dawn they sink back into the twilight zone and continue releasing it there. Over the course of a day, over the course of a year, over the course of the geological time during which this migration has been occurring, the quantity of carbon actively transported downward by this daily movement is significant. It is not merely the dead plankton falling as marine snow. It is the living animals themselves riding an elevator from the surface to the deep and back, and in riding it, transporting carbon in both directions simultaneously, up as body mass during the nightly ascent, down as excretion and respiration during the daily rest. This is what oceanographers call the biological pump, and the diel vertical migration is a major active component of it. The carbon carried downward by migrating animals each day contributes to the ocean's capacity to sequester carbon, to take it out of the atmosphere, and put it somewhere it will not affect the climate for a very long time. It is not the whole of the biological pump, and the biological pump is not the whole of the ocean's carbon cycle, and the ocean's carbon cycle is not the whole of the climate system, but it is a real and quantified contribution. The nightly migration is not just a wonder, it is a mechanism. It is part of the machinery by which this planet regulates itself, and it connects, in this way, the smallest animals in the sunlit world. Copepods, smaller than a grain of rice, krill you could hold 100 of in your palm, to the deep, cold dark of the midnight zone 1,000 meters below, and to the chemistry of the atmosphere above, and to the temperature of the air you are breathing right now as you read these words. The migration is not separate from your world, it is woven into it. The marine snow continues to fall, past the anglerfish, past the atolla, past the hunting ground of the sperm whale, downward, always downward, through the slow dark. The particles are smaller than they were when they formed at the surface because they have been intercepted and reprocessed many times on their journey down through the twilight zone. Some portion of them will be intercepted again here, in the midnight zone, by whatever patient, slow-metabolizing creature happens to be in their path, but a portion will not. A portion will drift through the midnight zone as well without being intercepted, still falling, still patient. There are places below the midnight zone we have not finished the descent. The water grows colder still, and the pressure continues its steady, relentless climb, and the snow falls past us as we sink, and somewhere far above, still moving, still rising in the dark of the surface night, the great migration continues its ancient rhythm. The copepods ascending, the lanternfishes following, the krill in their swarms making their way toward the pasture, the whole enormous pulse of life rising with the dark as it has risen every night for longer than the continents have held their current shapes. We are below it now, below the migrants, below the hunters, below the cold light of the mesopelagic and the deeper cold darkness of the midnight zone where the anglerfish hangs its lantern and the squid watches with its vast eyes and the atolla waits with its wheel of fire. Below us, 4,000 meters down, the midnight zone gives way to something else. The abyss is waiting. And below the abyss, deeper still, in the cuts and folds of the seafloor where the tectonic plates have rifted apart or ground one beneath another and left trenches that descend below the abyss itself. Below all of that, named for the god of the underworld because there is no bleaker, more final, more absolute environment that this planet contains, the Hadal zone is waiting too. The marine snow falls into both of them, steadily, without haste. And so we go on. 4,000 meters below the surface of the sea, the midnight zone ends without ceremony. There is no wall, no marked boundary, no change in the color of the water. The water has had no color for a very long time. There is only the continuing weight of the world above and the continuing cold, and the marine snow still drifting past as it has drifted through every zone above this one, unhurried, perpetual, carrying its cargo of the dead toward the bottom. This is the abyssopelagic zone, the abyss, named not for myth, but for the Greek word meaning bottomless, which is how it must have seemed to every human mind that tried to imagine it before we had the instruments to measure it. 4,000 meters down to 6,000 meters down roughly, though the ocean does not observe these boundaries with any precision. It simply continues. The pressure here is somewhere between 400 and 600 atmospheres depending on where you are within it, between 400 and 600 times the pressure of the air pressing on your skin right now as you lie still in the dark. That is a number that the body cannot hold. You can say it, you can write it, but you cannot feel it. The best analogy is not a comfortable one. It is like the weight of dozens of fully loaded jumbo jets pressing down on an area no bigger than your thumbnail. Every square centimeter of your body at this depth would bear a load that would close every blood vessel, compress every cavity, collapse every airspace inside you instantly. And yet life is here. The abyss is not crowded. Nothing in the deep ocean is crowded, not the way a coral reef is crowded, or a tidal pool is crowded, or a forest floor after rain is crowded with small, moving things. The abyss is vast and dark and profoundly, almost incomprehensibly empty by the standards of the sunlit world. But it is not sterile. The marine snow falls here as it falls everywhere else, and where food falls, something will eventually arrive to collect it. The creatures of the abyss have adapted to a world of almost no energy. Think of them the way you might think of an old clock wound very slowly, or a fire built from the damp wood at the edge of a forest. Burning, but barely, conserving every spark. The animals that live here have metabolism so reduced that they move infrequently, breathe infrequently, eat infrequently. They can wait. They are extraordinarily patient. A fish in the abyss may go weeks between meals and show no particular sign of distress. A shrimp may spend years moving only when it must. Everything here is oriented around the problem of energy scarcity. How to get enough of it, how to spend as little of it as possible, how to survive in a place where every calorie is a gift that fell from somewhere far above. The temperature here is close to 2 degrees Celsius. Not quite freezing because salt water freezes at a lower temperature than fresh, but close enough to feel like the cold at the edge of a walk-in refrigerator. The cold that presses itself against your forearms and makes you want to move quickly and get out. Except there is no getting out of the abyss. The cold is not a condition here. It is the permanent state of things, unvarying, the same at noon and midnight, the same in January and July, the same as it was 10,000 years ago and the same as it will be 10,000 years from now. The abyss is the most stable habitat on Earth. Nothing changes here. Nothing fluctuates. The temperature does not rise or fall with the seasons. The pressure does not shift with the weather. The darkness never lifts. It is a place of extraordinary constancy, which is itself a kind of comfort, if you are the kind of creature that has learned to live within it. Above us, if we could look up through the miles of black water, the nightly migration is still underway, the copepods rising, the krill ascending toward a surface we cannot see from here, toward a darkness warmed by the memory of a sun that set an hour ago. The whole great pulse of the diel vertical migration happening above us like a slow heartbeat of the ocean, a breath that the planet takes every day and releases every morning. We are below that breath now. We have sunk past it. The marine snow keeps falling past us. And as we continue to sink, we are approaching a boundary that is not marked on any physical map of the water, that exists only as a designation humans have imposed on a continuous column of ocean. But that is meaningful nonetheless. 6,000 meters. Below 6,000 meters, the ocean has a different name, the Hadal zone, named, as the dossier of this descent has already noted, for Hades, the Greek god who ruled the world of the dead, the underworld, the place below all other places. The name is not melodrama, it is almost literal. The Hadal zone is defined by the existence of deep ocean trenches, places where one tectonic plate has slid beneath another over millions of years, or where the seafloor has rifted open along deep fissures, and the result is a topology that descends below even the general level of the abyssal plain, cuts and grooves in the bottom of the world that go down further than down, that reach into a darkness below the darkness, under pressures that even the abyss cannot match. There are trenches scattered across the planet's ocean floors. The Tonga Trench, the Philippine Trench, the Puerto Rico Trench in the Atlantic, the South Sandwich Trench, but none of them descend as far as the one we are sinking toward now. The Mariana Trench sits in the western Pacific Ocean, northeast of the Mariana Islands, in a part of the ocean floor that is itself already among the deepest on Earth. And within the Mariana Trench, at its southern end, is a specific depression that oceanographers have named the Challenger Deep, named for HMS Challenger, the British survey vessel that first sounded it in 1875 and returned a depth measurement that the scientists aboard could barely believe. The Challenger Deep descends to approximately 10,935 meters below the surface of the sea. Measurements vary by a few meters. The bottom of such a place is difficult to map with precision, and different surveys using different instruments have returned slightly different numbers over the decades, but the figure is broadly agreed upon: 10,935 meters, nearly 11 kilometers. And to give that number the shape it deserves, if you took Mount Everest, at the highest point on the surface of the Earth, rising 8,849 meters above sea level, and you lowered it gently into the Challenger Deep, it would disappear entirely beneath the surface, and there would still be more than 2 kilometers of water above its summit. 2 kilometers of black, crushing, silent water above the peak of the highest mountain that has ever existed above the ground we walk on. The pressure at the bottom of the Challenger Deep is over 1,000 atmospheres, more than 1,000 times the pressure of the air around you right now. It is the most extreme environment on the surface of this planet, which means on the surface of any planet we have ever visited or measured or imagined with any credibility. And something lives there. We will come to that. But first, we must sink through the transition between the abyss and the trench itself, through 6,000 meters and 7,000 and 8,000, the pressure rising steadily. 1 atmosphere for every 10 meters, always, without variation, the physics of water being what they are, and the marine snow still falling past us, thinner now, much of it having been intercepted at the layers above, but still present, still drifting, still making its slow, patient way toward wherever the bottom is. At around 8,000 meters, something changes, not visibly, not in any way that would register as a change in the water itself, or the darkness or the cold. But in the biology of the world around us, a threshold is being approached. There is a molecule, a small one, trimethylamine N oxide, TMAO for short. It accumulates in the cells of deep-sea fish, and it has a specific job. It stabilizes proteins. Proteins, the molecular machinery that runs every biological process in every living thing on Earth, are sensitive to pressure. At ordinary pressures, the kind experienced by fish in shallow water or in the mesopelagic, or even in the upper midnight zone, proteins fold into the shapes they need to fold into and perform their functions without difficulty. But as pressure increases with depth, it begins to interfere with that folding. The same force that would crush your body at depth acts at the molecular level too, deforming the shapes that proteins need to adopt in order to work. TMAO counteracts this. It acts as a chemical prop, a brace against the pressure, keeping the molecular machinery of a fish's cells functioning in conditions that would otherwise make biochemistry impossible. The deeper a fish lives, the more TMAO it contains. This is not a coincidence. It is an adaptive response accumulated over evolutionary time as fish colonized progressively deeper water and required progressively more of the molecule to keep their cells working. Scientists studying Hadal fish, particularly Alan Jameson and his colleagues, who have done much of the definitive work on Hadal biology, found that the concentration of TMAO in fish tissue rises steadily and predictably with depth. And they found something else. There appears to be a ceiling, a point at which the concentration of TMAO that a fish's cells can contain reaches its functional maximum, beyond which adding more does not help and may even begin to cause its own problems. And that ceiling corresponds to a depth of roughly 8,400 meters. Below approximately 8,400 meters, the physics of pressure appear to overcome any biological adaptation that fish, as a group, have been able to evolve. The TMAO defense runs out. The proteins cannot be stabilized against pressures that extreme. And so fish, as far as we currently know and as far as the evidence strongly suggests, cannot live below roughly 8,400 meters. The deepest fish ever recorded, as of recent expeditions, was a snailfish, or a member of the family Liparidae, filmed at a depth of approximately 8,336 meters in the Izu Ogasawara Trench, a Hadal trench east of Japan. A specimen was also caught at around 8,022 meters in the same region. These are extraordinary depths. These snailfish are pale, almost translucent creatures, small and unassuming in the way of animals that have no predators and no need for camouflage in a world with no light to make camouflage meaningful. They look fragile, which they are. Brought to the surface, the change in pressure destroys them, which is why studying Hadal life requires cameras and traps that can be sent down and retrieved rather than the trawling methods used in shallower waters. But in their own environment, at 8,000 meters under pressures that would instantly obliterate any creature not adapted to them, these snailfish are the apex predators of their world. There is nothing in the Hadal zone that hunts them. They hunt amphipods, the small scavenging crustaceans that swarm the trenches in their millions. The Hadal amphipods deserve a moment. They are not what you would think of if someone described a crustacean to you. They are not the elegant shrimp or the armored crab of shallower waters. They are pale, elongated, almost ghostly things. But they have adapted to the Hadal in ways that go beyond mere tolerance of pressure. In the Mariana Trench, one species of Hadal amphipod, Hirondellea gigas, has been found to possess something remarkable in its exoskeleton, an aluminum-based gel that reinforces the shell, a kind of biological armor incorporating a metal that the animal extracts from its environment. Aluminum, which does not appear in the exoskeletons of amphipods in shallow water. In the crushing, dark, cold reality of the deepest trench on Earth, this small crustacean has found a way to incorporate one of the most abundant metals on the planet into its body as reinforcement against a world that wants to destroy it. They swarm to food. They can detect a food source and converge on it with remarkable speed for animals of their size in an environment of such extreme pressure. Send a baited camera to the bottom of a Hadal trench, and within hours it will be surrounded by amphipods, pale and purposeful in the lights of the camera, working at whatever has been provided with a quiet, relentless efficiency. They are the cleanup crew of the deepest water on Earth, and they perform their function with a thoroughness that the environment demands. And here, in the midst of this description of the most remote place on the planet, there is a note that must be made, a quiet one, a single chord of something uncomfortable in an otherwise restful descent. Plastic has been found in the guts of Hadal amphipods from the Mariana Trench. Polychlorinated biphenyls, PCBs, industrial chemicals banned in many countries for decades, have been detected in the tissue of amphipods from the deepest trenches on Earth, at concentrations higher than in many of the world's most heavily contaminated coastal waters. The work of Alan Jameson and his colleagues has documented this carefully. What it means is this: the most remote environment on the planet, 11 kilometers below the surface, accessible only to the most extreme scientific expeditions and visited by only a handful of humans in all of recorded history, has already been reached by the things we have put into the water above it. Marine snow carries everything the upper ocean contains, and the upper ocean contains what we have put into it. The particles drift down through every layer, past the migrants and the hunters, and the glowing dark, past the marine snow that has always drifted, and they arrive at the bottom. This is the only note of sorrow in this descent. It is not a lecture, and we will not dwell on it, because the wonder here is too vast and too old to be swallowed by sadness. But it is true, and truth is part of what we carry with us into the dark. There is more life here than sorrow, and older. Below the fish, below the zone where TMAO and physics impose their ceiling, the amphipods continue into deeper water. And at the very bottom of the Challenger Deep, in the sediment of the trench floor itself, there are microorganisms, bacteria and archaea. The ancient single-celled life forms that predate everything else we have discussed on this descent, surviving in conditions that until very recently we would have said were incompatible with life. They metabolize slowly. They reproduce infrequently. They live in the sediment at the very bottom of the world, and they go about their business in the way that bacteria have gone about their business for billions of years, indifferent to depth and pressure and darkness and the absence of sunlight, because they never needed sunlight in the first place. Which brings us to something else: the hydrothermal vents. In 1977, a scientific expedition in the research submersible Alvin descended to the Galapagos Rift, a section of the seafloor in the eastern Pacific Ocean where two tectonic plates are slowly pulling apart. The researchers were expecting to find the usual abyssal terrain, cold, dark, empty of large life, except for occasional scavengers. What they found instead was among the most significant biological discoveries of the 20th century. Superheated water, rich in hydrogen sulfide and other chemicals, was venting from the seafloor through chimneys and cracks and fissures, and around these vents, in complete and perpetual darkness, in water of extreme temperature and chemical composition, there were communities of life that no one had predicted and no one had imagined. Tube worms 3 meters long, their plumes swaying in the currents around the vents, giant clams, shrimp, crabs. An entire ecosystem, dense and varied and obviously thriving, in a place where, until that moment, science had assumed nothing could thrive. The ecosystem was not running on sunlight. It could not be. There was no sunlight here, and there had never been. It was running on chemistry. The bacteria and archaea living around the vents were performing a process called chemosynthesis, converting the chemicals venting from the seafloor, hydrogen sulfide primarily, but also methane and other compounds, into energy, the way that plants at the surface convert sunlight into energy through photosynthesis. And those bacteria formed the base of a food web that supported everything else around the vent. The tube worms had bacteria living inside them in a symbiotic relationship, the bacteria providing nutrition, the tube worm providing shelter. The clams had bacteria of their own, the shrimp grazed on bacterial mats. Life had found a way to exist with no connection to the sun at all. This was a paradigm shift so fundamental that it required a rethinking of the very definition of the habitable zone of life on Earth, and by extension, the habitable zone of any planet. Before 1977, it was reasonable to assume that all life ultimately depended on sunlight, that the sun was the indispensable engine of every ecosystem on Earth. After 1977, that assumption was gone. Life can run on chemistry. Life can run on the heat of the planet's own interior, on the minerals venting from cracks in the seafloor, with no photon of solar radiation ever having touched any part of it. The vents were not the same as the rest of the deep sea, and are not the same as the Hadal trenches. They are oases, warm, chemically rich islands in the cold, dark plain of the abyssal seafloor. They do not appear everywhere. They appear where the geology allows, where plates are moving, and the crust is thin and the heat of the Earth's interior can find its way up through the rock. But where they appear, they support communities of life that are dense and diverse, and often very old in evolutionary terms. Communities that have been isolated from each other and from the surface world long enough to develop species found nowhere else. And then there is the other form of abundance that the deep floor knows, the kind that comes not from chemistry and heat, but from the surface world, falling slowly through all the layers of water above. A whale dies. It dies at the surface, or near it, for most of the great whales live and feed in the upper ocean, in the sunlit zone and the mesopelagic, where the krill swarm and the fish migrate, and the productivity of photosynthesis supports the food web that supports everything up to and including the largest animals that have ever lived on this planet. A whale dies, and its body, enormous, dense, rich with fat and protein and every nutrient the ocean contains, begins to sink. Not quickly. A whale carcass is buoyant at first and may float at the surface for some time before the gases of decomposition and the breakdown of tissues alter its density, and it begins its descent. But eventually it sinks. It sinks through the epipelagic, past the level where the red light died. It sinks through the mesopelagic, past the level where the deep scattering layer hangs in the day, and through which the lanternfishes migrate at night. It sinks through the bathypelagic midnight zone, past the anglerfish and the atolla, and the colossal squid with its dinner plate eyes. It sinks through the abyssopelagic abyss, where the temperature is 2 degrees and the pressure is crushing, and the marine snow falls around it as it falls. And at some point, if the trench is nearby, if the geometry of the seafloor permits, it may reach the Hadal. When a whale carcass reaches the deep sea floor, something remarkable happens. It does not simply decompose, it becomes, instead, an ecosystem. A whale fall, as oceanographers call it, is a sudden, enormous, concentrated input of organic material into a world that normally receives only the thin, dispersed trickle of marine snow. It is, by the standards of the abyss, a catastrophic abundance, an event so far outside the normal conditions of deep-sea life that the organisms that consume it have evolved specifically to exploit it. A whale fall proceeds through stages over years and decades. First, The mobile scavengers arrive, sleeper sharks and rat-tail fish and deep-sea crabs, if any, are within range, stripping the soft tissue from the carcass in months. Then, enrichment opportunist species colonize the bones, polychaete worms, crustaceans, mollusks, exploiting the enriched sediment around the carcass, and finally, sulfophilic bacteria, cousins of the chemosynthetic bacteria that colonize hydrothermal vents, colonize the bones themselves, breaking down the lipids stored within them, producing hydrogen sulfide, and supporting a community of chemosynthetic life that can persist around the whale skeleton for decades. A single large whale carcass can feed a deep-sea ecosystem for 50 years or more. 50 years of productivity from one animal's death, slowly unfolding on the dark floor of a world that otherwise waits patiently for the slow, thin snow from above. Scientists have found over 60 species at whale falls that were also found at hydrothermal vents, the same chemosynthetic specialists living at both. There is a hypothesis, tentative but elegant, that whale falls may have acted over the millions of years of whale evolution as stepping stones across the deep seafloor, isolated islands of chemosynthetic abundance spaced across the abyssal plain, allowing organisms to colonize from one vent system to another by island hopping across the bones of the dead. Life using life to travel through the dark. And now we have reached the bottom of the descent. We are at the deepest point that this planet contains, the sediment of the Challenger, deep beneath us, the water column of almost 11 kilometers above us, the pressure of over 1,000 atmospheres pressing in from every direction with a force that is beyond the reach of any analogy that can be made comfortable. The marine snow that has been falling beside us through this entire journey has finally arrived. Some portion of what fell from the sunlit surface tonight has made it all the way here, carrying the carbon that the phytoplankton fixed from the atmosphere, carrying the chemistry of the upper ocean, carrying the faint chemical signatures of everything that the surface world contains. It has taken days or weeks to arrive, but it arrived. And in the sediment here, bacteria live. That is the end of the descent. Or rather, that is the bottom of it. But it is not the end of the story. The story has a different shape than a simple descent. It is not a line going down. It is something more like a breath, a cycle, a rhythm that the ocean takes on its own terms and that has been taking it without interruption since long before any eye existed to see it. Only a handful of humans have ever been where we are now, even in the imagination. The first were Jacques Picard, a Swiss oceanographer, and Don Walsh, a United States Navy lieutenant, who descended in the bathyscaphe Trieste on the 23rd of January, 1960 and reached the bottom of the Challenger Deep, a feat that remains one of the most audacious acts of exploration in the 20th century. They spent about 20 minutes on the bottom, looking out through thick acrylic windows at a seafloor they could barely see before ascending again. The Trieste was a vessel of extraordinary engineering, a float filled with gasoline for buoyancy, a steel sphere for the crew, weighted with iron shot that could be released to allow the vessel to rise. It was not elegant, it worked. And then for more than half a century, the bottom of the Challenger Deep was not visited by any crewed vessel. 52 years passed, the world changed almost beyond recognition. Computers became pocket-sized, humans walked on the moon 6 times, the internet arrived, and the bottom of the deepest ocean on Earth went unvisited because going there was extraordinarily difficult and expensive and dangerous, and because the deep ocean is not where the currents of human attention tend to flow. In 2012, James Cameron, the filmmaker, descended solo in a specially constructed submersible called Deep Sea Challenger. He reached the bottom, spent time there collecting samples and footage, and returned. Since then, Victor Vescovo and others have followed, using newer technology and achieving multiple dives to the Hadal floor of the Challenger Deep and other trenches. The number of people who have reached the deepest point in the ocean in all of recorded history is very small. Far more people have stood on the summit of Everest, that mountain that would drown entirely with room to spare, than have touched the floor of the trench that would swallow it. The deep ocean is our own planet, and we have barely visited it. This is not a failure, it is simply a fact about scale and difficulty and the still young history of our ability to go where the physics of pressure say we should not go. We have mapped more of the surface of Mars in certain respects than of our own seafloor. A large fraction of the ocean bottom has never been imaged at high resolution. The largest habitable volume on Earth, below 200 meters, encompassing the mesopelagic, the midnight zone, the abyss, the hadal, remains in most of its extent unknown to us in any detailed sense. We know it exists, we know in broad terms what it contains. But the specific topography of most of it, the specific species that live in most of it, the specific ecology of most of it, these remain unmeasured, uncatalogued, not yet fully part of our understanding of the world we live on. And yet the world does not wait for us to understand it. The migration does not pause for the lack of human observation. Every night, as it has done since long before any human thought to wonder about it, the largest movement of life on Earth takes place in the dark. Think of that for a moment. Hold it gently in the mind as you might hold a stone found on a beach. Something old and smooth that fits easily in the hand, that asks nothing of you except that you notice its weight. Right now, as you lie still in whatever darkness surrounds you, somewhere on the ocean the sun is setting or has just set. And where it is setting in the water below, in every ocean, at every longitude, where night is falling, billions upon billions of small animals are beginning to rise. The copepods first, perhaps. Tiny crustaceans the size of a grain of rice, ascending through hundreds of meters of cold, dark water toward the food-rich surface, bodies not much bigger than punctuation marks, making a journey proportional to their size that no marathon runner on a sunlit road has ever matched. The krill behind them, Euphausia superba and its relatives, rising in swarms so dense that sonar reads them as a false seafloor, the echo of their gas-filled bodies bouncing the sound back up to the ship and confusing the instruments of sailors who were, for a moment in the middle of the last century, briefly certain they had found a bottom that was not there. The lanternfishes, the Myctophidae, possibly the most numerous vertebrates on Earth, billions of them carrying their rows of glowing photophores up through the twilight zone and into the dark surface waters, rising to feed, to eat the copepods that have risen before them, to be eaten in their turn by whatever is larger. The squid and the predatory fish following the bioluminescent streams upward. All of it happening in the dark, all of it happening right now as you breathe slowly and your thoughts begin to lose their edges and the day recedes. And every one of those animals before dawn will descend again. They will carry with them the carbon they have fixed at the surface, the organic matter they have consumed in the sunlit zone, and they will take it down, some of them to the mesopelagic, where they will respire and excrete in the dimming blue, some to the midnight zone, some to depths we cannot easily measure. The biological carbon pump working its quiet planetary function, moving carbon from the atmosphere, through the algae, through the bodies of the migrants, down through the layers of the ocean, below the depth where it can return quickly to the air. The diel vertical migration is not just the largest movement of life on Earth, it is part of how the ocean breathes, part of how the planet regulates itself, a function so ancient and so constant that it was already old before the first fish evolved, running then on the plankton and the primitive grazers of the Cambrian Sea, or older still. The ocean does not know that we are watching or thinking about it or trying to understand it. It does not need us to understand it in order to continue. The migration will happen tomorrow night the way it happened last night, the way it happened 100 million years ago. The marine snow will fall, the lanternfish will rise, the anglerfish will hang its bacterial light in the midnight zone and wait. The snailfish will patrol the floor of the Izu Ogasawara Trench at 8,000 meters, hunting its amphipods in the crushing dark, carrying in its cells the molecule that keeps it alive where nothing else like it can survive. The amphipods will scavenge. The bacteria at the vents will convert the chemicals of the Earth's interior into life without sunlight, without any reference to the world above, as they have done since long before sunlight was even a condition that life had learned to use. All of this is happening, not in a story, not in a documentary, in the actual ocean, which is below the actual surface of the actual world you live on right now, tonight, in the dark. There is something in that fact that does not require any elaboration. It simply is. The deep ocean is the largest living space on Earth, and it is almost entirely dark, and it is almost entirely in motion. The slow motion of the snow falling, the rhythmic motion of the migration rising and descending, the infinitesimal motion of the bacteria doing their ancient chemistry at the bottom of the trenches. It is alive in ways we are still learning to count and name and understand. The estimate of mesopelagic fish biomass revised in 2014 by Irigoyen and colleagues from the Malaspina expedition suggested that there may be on the order of 10 billion tons of fish in the twilight zone alone, roughly 10 times what older estimates had proposed. We thought we knew the ocean. We were wrong by a factor of 10 about a habitat that covers most of the surface of the planet. And that is a beautiful kind of wrong, the kind that means there is more wonder, not less, more life, not less, more strangeness and depth and darkness and glowing creature and slow chemistry and falling snow than we imagined, waiting in a world that is technically part of the same planet you are sleeping on tonight. The Challenger deep sits in its place in the Western Pacific, its walls dropping to their extraordinary depth, the amphipods moving across the sediment at the bottom, the bacteria doing what bacteria have always done, the snailfish, if one happens to be in range of that floor, hanging in the water column and waiting with the patience of a creature that has no concept of waiting because waiting is simply existence here. And from the bottom of the Challenger Deep, if you could somehow look up through the 11 kilometers of water above, you would see nothing. No light. Not even blue. Not even a hint of blue. The column of water above is too long, too dark, too full of the absorbing sea for any photon from the surface world to reach this depth. But somewhere in that invisible column above you, in the mesopelagic twilight, the lanternfishes are descending with the coming of dawn, their photophores winking out or dimming, their bodies carrying them back down to the depth where they will rest in the day. Somewhere above the lanternfishes, the surface is lightening toward morning. The copepods are descending, the krill are sinking. The great pulse of the migration is reversing itself, as it reverses itself every morning, as it will reverse itself tomorrow morning, and the morning after that, for as long as the earth continues to turn and the sun continues to rise and set over an ocean that is very old and very deep and very much alive. The snow falls through all of it, through the lightening surface and the fading blue, and the twilight and the midnight and the abyss, and down to the Hadal sediment, carrying the day's carbon into the dark. And somewhere in the world right now, perhaps, someone is lying on a ship in the middle of the ocean and looking up at a sky full of stars with 10,000 feet of black water beneath them and the migration in full reverse below that, and they know, or perhaps they do not know, perhaps they simply feel, that the world is very much larger and stranger and more layered than the surface of it suggests, that the darkness below them is not empty, that it is, in fact, full. If you have followed this descent all the way from the surface, from the moment the sun set on the ocean and the first copepods began to rise, through the fading of the red light and the crossing into the twilight zone and the darkness of the midnight and the cold immensity of the abyss, if you have traveled that far tonight, then you have gone somewhere that very few humans have ever gone, even in imagination. And you can rest in it now. The ocean will continue without you. It does not require witness. The migration happens whether or not anyone is awake to think about it. Tonight, right now, it is happening. And that fact will still be true in the morning, when you wake, and the morning after that, and for every night of the rest of your life. The ocean is patient. It has been doing this longer than our species has existed. It will be doing this long after our names have been forgotten. There is something in that which is not bleak, but restful. To know that something enormous and ancient and completely indifferent to human worry is going about its business in the dark, the copepods rising, the snow falling, the snailfish waiting, the bacteria converting the chemistry of the deep earth into something that deserves the word living, is to feel perhaps how small one day's concerns really are. Not small in a diminishing sense, small in a freeing one. If you are listening from somewhere in the world tonight and you want to share where that is, I would genuinely like to know. The ocean connects every shore, and the migration happens under all of them. The comments are there, and I do read them. There are more stories here of this same slow and careful kind, waiting for whenever you want them. But tonight, this is where the descent ends, on the sediment of the Hadal floor. In the dark, in the quiet, in the middle of the largest migration on Earth, which is happening right now, and which you can rest inside of without needing to see it or measure it or understand every part of it. It is enough to know it is there. Like the old Stoics, let the day go, tomorrow can be tomorrow's. Good night, sleep well,